Hey guys, welcome to the video in which we're going to be multiplying rational expressions. Now, multiplying rational expressions is super easy. It's actually basically just a big problem of simplifying. But if we remember when we're multiplying fractions in general, we just take, let's say we had 3/4 and we're going to multiply it times 2/5. All we have to do is multiply the numerators and denominators separately. So this would be 3 times 2 and 4 times 5, and then of course we would reduce that always. Another thing you can do when we have multiplying fractions is canceling out common factors in the numerator and the denominator. So we know these are going to be combined. Well, right away I could make this a 1 and this a 2, which 3 times 1 would right away give me 3, and 2 times 5 would give me 10. We can do the same thing when we multiply rational expressions. In fact, we want to factor first so that we can cancel anything out so we don't make our expression more complicated and have to factor at the end. So let's get to work. Multiply the rational expressions, identify any excluded values. Okay, so starting with letter A, remember we are always going to factor first. So I'm going to look at the numerator of the first fraction. I'm going to write 3x squared as 3 times x, and then my denominator is x squared minus 2x minus 8. I'm factoring. What multiplies to negative 8 adds to negative 2. That would be a negative 4 and a positive 2. So x minus 4 times x plus 2. Okay, nothing canceling yet. Maybe when I factor the second fraction, I might see something. In my numerator, I have 2x squared minus 6x minus 20. All of those numbers are divisible by 2, so I'm actually going to take out a GCF of 2. All right, so pulling that out, that leaves me with x squared minus 3x minus 10, which hopefully you see that is the exact same thing we have in the denominator. So those are definitely going to cancel. However, because we have to identify the excluded values, we still want to factor that expression. So what multiplies to negative 10 adds to negative 3? That would be a negative 5 and a positive 2. So x minus 5 times x plus 2. So when we look at these, let's identify our excluded values before we cancel anything out, because we have to look at what started the problem. Because those are going to be excluded the whole way. So first of all, I have x plus 4. What would make that 0? That would be a positive 4. So that's x minus 4. So x cannot equal positive 4. Then I have x plus 2. That would be x cannot equal negative 2. And finally, x minus 5, x cannot equal positive 5. This is x plus 2 again, and I've already covered the negative 2. Okay, so as we already saw, we know this entire trinomial will cancel. But that's really all we have that's consistent in the numerator and the denominator. So let's put these back together. So in my numerator, I'm going to go multiply numerator times numerator. Well, let's multiply 3 times 2, that's 6, and write this as x squared. Don't leave that as x and x. But you can just leave the denominator as x minus 4 times x plus 2, and then also your excluded values are part of your answer. Okay, we're going to do letter B. The first thing we are going to do is factor the numerators and denominators and see what we got. So in the numerator here, x squared minus 8x, I have a common factor of x, and I'm left with x minus 8. In the denominator, I have 14. That's just a constant, but I can factor that to 2 times 7, and that might be helpful. Also, I have this trinomial. What multiplies to 15 and adds to 8? Well, that would be 3 and 5. So x plus 3 times x plus 5. All right, nothing yet to cancel. Let's look at our second fraction. 7x plus 35. I could take a 7 out of both of those terms, and that would leave me with x plus 5. And then I just have x plus 8 on the bottom. So that's what we have left over. I will have 3 excluded values because I have 3 factors with an x in them. They would be negative 3, negative 5, and negative 8. And I can cancel, look at this, the 7 and the x plus 5. But that's all I can cancel because that's all that is exactly the same in the numerator and the denominator. So in my numerator, I have left x times